good evening to all of you. I'm Rahul Kumar. I am the instructor for this Hadoop Administration webinar to all of you, and thank you all for joining in. So, about myself, I am a senior instructor in Edureka, and I'm having around 12 years experience in Hadoop, big data technologies, Linux, Java. For this 1 hour, I'll be taking this webinar of powering the Hadoop cluster with Amazon Web Services Cloud. So, hope you hope you will understand the basics of Hadoop through this webinar, and you'll understand like how Edureka teaches in its Hadoop administration course. So thank you all for joining in, and let's start with our webinar of Hadoop cluster, Hadoop administration using the Amazon Web Services Cloud. So at the end of this module, you will be able to understand the Hadoop cluster introduction, recommended configurations for the cluster. So how when you build the cluster of Hadoop, what are the recommended configurations and what are the different running modes of Hadoop cluster? So there are various modes, and what all different modes you can configure a Hadoop cluster. What all different configuration files that you need to edit to build this cluster, and what will be the major Hadoop administration roles and responsibilities. So that's what we are going to talk about through this webinar. And in the end, I'll be just going through a quick demonstration of how you can set up a Hadoop cluster on Amazon Web Services Cloud. Okay, so thanks a lot, and let's now start the technical aspect of what Hadoop core components are, what is Hadoop administration all about. So Hadoop 2.x core components, when we talk about Hadoop, Hadoop is a distributed framework where there are two major components of Hadoop. One is called distributed file system, which is the storage architecture of Hadoop that provides all the block level storage and then replication factors and all, where the processing part comes with the yet another resource negotiator or yarn. So processing is basically dependent upon two different components, two different daemons, which are called resource manager and node manager, and we have got three major components of Hadoop distributed file system, which is name node, data node, and secondary name node. So as the name suggests, secondary name node here is it's just a backup node of the primary name node. So what these components are actually doing, what these daemons are doing in the Hadoop cluster is like name node is storing all the metadata you are storing in the Hadoop distributed file system. So it does store all the data about data, like file timestamps, block level, block replications, number of blocks, block size, etc. While the data nodes, they store all the blocks of the data. So there's a question from one of the guys as well that before going, is it really better to go for the Hadoop administration of Hadoop developer? So Hadoop administrator, I would suggest here, I mean both are really recommended. I won't say really that you should go for only Hadoop administration. Go for both the courses because both are really growing up. Both are the latest one into the market, and lot of requirements are there in the Hadoop markets when we talk about the big data technologies and all. So I would say, Sandeep, I mean go for both the kind of courses. Not I will say that only go for Hadoop administration or Hadoop development. Okay. So one important point I would like to highlight here: the Hadoop administration course or Hadoop administration activities will give you the real insights of what Hadoop cluster is all about, and that will help you. I mean, if you have a lot of development stigma to do the applications, to develop the application, to build the products, then that will really help you to build the products from inside or outside. I mean, it will really help you guys to make the product more bug-free. Okay, so let's just continue the things, and probably I'll answer the questions as we go along. Is it okay, guys? So right. So Hadoop two core components I was talking about: name node that stores all the metadata, and then data node that stores the actual metadata. Okay, and then you have got the secondary name node, which is just the backup of the primary name node here. Whereas you have got yet another resource negotiator, which is composed of two different daemons called resource manager and the node manager. So resource manager is like doing all the resource management of the cluster while running the job, and the node manager is doing the node management. So resource management for each node in the cluster. Resource manager for every node in the cluster will be done by the node manager, and resource management of the whole cluster is being done by the resource manager only during the processing of the job. Okay, while there is one more daemon which is called application master, which is not being shown here, which does only the which runs only for the life cycle of the application, and which will help with the application to get all the resources for running that particular application. So if you see the architecture of Hadoop, I mean the typical use case of Hadoop from the cluster administrator's point of view, uh, you have got two name nodes, active and standby name node, basically to build the high availability into the name node, and you have got multiple data nodes that are connected to it. So in the high availability scenario, I mean in general as well, I'll say, so name node always will be composed of more RAM and less hard disk comparing to the data nodes. If you see, where the data nodes have less RAM and the more hard disk, because the actual data goes into the data nodes, and the metadata goes into the name node, which actually loads into the RAM itself, which loads into the primary memory. So optionally, you can have secondary name node in this case, because the secondary name node will be the backup of the primary name node, which already the secondary name node is doing. So you can also achieve the second high availability in the two different ways, via the quorum journal manager or via the network file system. So we do teach both the different ways when you achieve the how do you achieve the high availability in the Hadoop cluster architectures. So the data nodes are always composed of more amount of hard disk, because they are going to store the actual data in the cluster. So as I just said, that HDFS is composed of two different daemons, name node and the data nodes. So data nodes store all the data in the form of blocks. Name node stores only the metadata of that data. So metadata contains block locations, file locations, blocks associated with the file, timestamps, etc. So, and the actual data is always being stored of the data nodes. So why we always have data, a secondary name node always half the size of the RAM. So it should be actually same. I mean, ideally it should be same, but you can have a half of it. Okay, so the main thing is, I mean, if you see, there's one keyword written over secondary name node as optional, because secondary name node is not really recommended in the Hadoop cluster. Okay, why? Because I mean, it actually does the checkpointing every hour. Okay, which means if it has done the checkpointing at 11 o'clock, then the next checkpoint time is 12 o'clock. Okay, that's the default timings it has. So let's say your name node has gone down at 11:55. Okay, so secondary name node will not be having the 55 minutes of metadata, which means your data of 55 minutes is lost. Okay, so that is why it is recommended to have the high availability in the Hadoop cluster, which is composed of active name node and the standby name node. But yes, if you are keeping the secondary name node, then it is quite okay to have the secondary name node also with the same amount of hardware capacity as that of active name node. But keeping it half is also okay, because you're not going to really make the secondary name node as powerful as active name node. I mean, you're not going to replace the active name node with the secondary name node in any ways. So if you're designing your cluster, I mean, this is one important way to design the cluster. Let's say cluster growth based on the storage capacity. Now there are multiple ways. I mean, if you think about the cluster architecture, then you can also design the cluster with the amount of processing power or the memory or the storage. So if you're talking about the storage, this is often a very good method to use. For example, if your data is growing approximately by 5 terabytes per week, and replication factor is set to 3 times in the HDFS, then 15 terabytes of extra storage space is required every week, which means, assuming an overhead of 30% for the non-HDFS usage, you need one machine every week, which is composed of 5 into 3 terabytes of hard disk drives. So how you build the cluster, you always think about the future before you build the cluster, because Hadoop certainly has the capacity of commissioning or decommissioning the nodes on the fly, but when you are putting the data into the cluster, when you are actually storing the data into the nodes of the cluster, how you are going to do the capacity planning is very important to do from the futures perspective. So you take at least 6 months to 12 months of the contingency that, okay, if I have this much of data I'm going to store in the next 12 months or so, how much of data nodes are going to take, how much of space they are going to take in the Hadoop cluster. So you need to always have that kind of visibility in the Hadoop cluster itself. So talking about the hardware of these nodes, I mean, so we talk about the slave nodes, the recommended configuration. You can see general configuration is like 16 to 22 or 32 gigs of RAM. So I recommend, I mean, generally 24 to 32 gigs of RAM, and the baseline configuration I'll say is like 6 into 2 terabytes of hard disk drives. Now, there are like, this is just a baseline configuration. This is not something which you will always see in your organizations or in any organizations. Okay, it might be this I mean, in this way, or it can be like 14, 16 terabytes of hard disk drives kind of thing. It can differ from organization to organization, application to application, and project to project. So that totally differs. But the main idea behind, I mean, putting these slave nodes with this special configuration is buy more nodes. Okay, save the money, buy more nodes, because more the number of nodes, more the distribution of data will be, and less the pressure on the nodes for the processing. So more the number of nodes, if a cluster with more nodes performs better than one with fewer, slightly faster nodes. This is rightly said because more the number of nodes, less the pressure on the data nodes itself for the processing part. So this is the general configuration you can always think about. 4 into 1 terabytes or 2 terabytes of hard disk drives in a JBOD configuration. Now, one of the keywords in the Hadoop cluster is the JBOD, which is called just a bunch of disk, which means you are providing the data, you're providing the disk in such a way that your data will go into the data nodes in a round robin fashion. And do not use RAID because already the Hadoop cluster is composed of the replication factors. Replication data is always going to get duplicated in the Hadoop cluster with the default settings of 3. If you are changing it, then certainly it will be the user configuration value. So 2 into quad core CPUs, 24 to 32 gigs of RAM, gigabit Ethernet. While we have a special configuration as well, multiples of 1 hard drive plus 2 cores plus 6 to 8 gigs of RAM generally work well for many types of applications. So you can see how small configuration it is. I mean, it not even, you cannot even compare it with the laptop. I mean, today's laptops are also composed of like 16 gigs or 32 gigs RAM. But yes, I mean, if you see multiple, if you have like 100 nodes with these special configurations, then they generally work well for many types of application. Now, from if you talk about like my experience, okay, I have seen both the configurations in the organizations. Okay, one organization with the 800 node cluster, okay, where 400 nodes were composed of special configuration and 400 nodes were composed of the general configuration. Now in the Hadoop cluster, it is totally fine, okay, to have the mixed architecture of a mixed capacity of the nodes. Okay, it's quite fine to have one node very strong and another node very weak. Okay, not recommended certainly, but depends upon the application. So the project requirement was such like to decommission the nodes on the fly. So we used to commission 200 nodes sometimes on the fly. Commissioning was going on. So we used to have like 400 nodes kept specially for decommissioning and commissioning purposes. Just if you need more number of nodes, let's add the 200 nodes for the project and give them the access to that. So it depends. I mean, it depends upon how your project is, how your architecture is. But certainly, I mean, if you are putting the slave nodes in such a way that if it's just a special configuration, then you should always be ready for how much of mappers, how many number of mappers or reducers you're going to put on those nodes itself. So generally, each mappers or reducer task will take 1 gigs to 2 gigs of RAM. Now, ideally, it takes actually 1.5 to 2 gigs of RAM, and you should not be using virtual memory, means you should not be using any hard disk drive as a memory for the slave nodes, and ensure enough RAM is present to run all the tasks plus the data node task tracker daemons, which means 1 gigs of RAM you should give to the data nodes, 1 gigs you should give for the task trackers, and 1 gigs to the operating system. Means if you are having a total of 8 gigabytes of memory, out of which 3 gigabytes you have given it to the data node task tracker and the operating system, then you are left with 5 gigabytes of the RAM. So total number of tasks, if you want to calculate on each slave node, is like 1.5 times the total number of processor cores. And if it is hyper-threading, if there is hyper-threading enabled, then multiply it by 2, which gives you the total number of mappers and reducers. You can divide it into the ratio of 2:1, and that's the whole scenario. That's the whole total number of mappers and reducers you can keep on each data node itself. Sorry, on each task tracker. So it's very important for a Hadoop cluster administrator or a Hadoop designer, I mean, to understand that how many number of mappers and reducers you are giving, or what should be the architecture of the nodes, or what should be the baseline configurations for the nodes, because you, I mean, once you have ordered all the operating system, once you have ordered all the hardware from the different vendors, hardware configurations, what are recommendations from the experience is what we have actually. So just to give you an idea about the hardware recommendation of name node or hardware recommendations, you can see dual, always go with dual power supplies, dual Ethernet cards, rated hard drives, minimum of 32 gigs of RAM, but today the recommended when I'll go for with the 96 gigs of RAM itself, 96 to 100 gigs of RAM, that's the minimum, because data is not going into the just terabytes or gigabytes, it is going into the petabytes. So more the number of, more the amount of data, more the RAM you need for the name node. And one of the most important point of a name node is, or a administration or a master node is carrier class hardware, which means enterprise class hardware, not the commodity hardware. Okay, you should always the best hardware for the master nodes. Okay, so guys, if you have any questions you want to ask, please go ahead. Okay, there was one question from one guy that how does the OLTP or overlap is differ from the Hadoop big data? See, OLTP is not being done in Hadoop right now. Okay, the reason is there is no such database that you can work as like with the speed of queries. I'll say HBase is there, Cassandra is there, MongoDB. Would really recommend you to have like file system, right? So Hadoop distributed file system, it stores all data format, which is a file format only, a normal file format. So anything you're doing, let's say you are doing is Spark, high processing, Impala processing, HBase processing, everything. So the baseline structure will always be Hadoop distributed file. Okay. Now this file system is not updatable. This file system has a lot of limitations of its own. So major use case of HDFS is to do the batch processing. Okay, now yes, there are a lot of different architectures, a lot of different ecosystem components there to modify this behavior, okay, in some or other way. But yes, major use case will be all the batch processing of the Hadoop distributed file system, which is like OLAP. Okay, so just taking an example here, you are bringing the data from Twitter into the HDFS, for which you are using a tool called Flume. After that, on that data, you are providing a structure with the help of Hive. You are writing the Impala queries to analyze the data. Okay, so you store the data into the Hadoop distributed file system. Okay, so there's a question that what is the point of now? There is no such traditional system like Oracle or Teradata or Netezza that can store 100 terabytes of data and do the batch processing in the very less amount of time. I mean, compared with the Hadoop, these technologies. Okay, there is no such technology in which you can decommission the nodes on the fly. So, okay, with so I mean, see, Hadoop says my expectation is my nodes are going to go down. I'm not going to, because I have such or characteristics. Okay, I have a lot of. I'm going to do all the balancing for you. Okay, you put any kind of, if you know only right map reduce, whatever. Okay, so I no problem. Okay, but if you are doing all the OLTP kind of things, okay, I'm going to store a lot of data. So don't do that. I'm not that skilled for the OLTP. Use some data. Cassandra comes into the picture. Okay, you are storing the data via Cassandra has all the features to OLTP, but it's not that really, I'll say matured RDBA. Okay, so do all the processing into HDFS or MapReduce. Okay, just taking an example here. Spark takes Spark stores all the data in HDFS, does all the processing in the memory. Okay, so it takes all the data from HDFS, does all the in-memory processing, and provides the output to. Now 1 petabyte. If you see the record of 1 terabyte, okay, now there is a record in the world. Okay, there is a competition which is open to anybody. You see that record there. That 1 terabyte of data has been processed in I believe 1 minute or something. Okay, so 1 terabyte of data has been processed in 1 minute. Okay, so it's very quick. Okay, you can't do that in Teradata or Netezza. Now, I mean, you can create your own application. You can give it a try if it really works out for you. Okay, so it's quite a challenge. I mean, Hadoop came first quite a couple of years back. I will say 2 or 3 years back. But now Spark has come into the picture. So that's what I'm saying. Distribution architecture is used by, I mean, it's only Hadoop, HDFS. But on top of it, you're using various applications. Like Hadoop does not provide any capabilities of scheduling the jobs. Okay, you can do via Uzi. Okay, Hadoop does not provide any way of storing the data in a database. HBase does that. Okay, you cannot store the data from Hadoop to RDBMS with using Hadoop. I mean, you need to use Scoop for that. That's why we do all the technologies in our administration course as well. How you can import, export the data using Scoop into Hadoop. I mean, via RDBMS, I'll say. If you want to import, export the data from RDBMS to Hadoop. Okay. If you want to bring the data from different sources, let's say there is a lot of streaming data coming up. How you will store the data into HDFS? Okay. If you want to schedule different jobs at different point of times, how will you do via Uzi? Okay. How will you create the database on top of a Hadoop cluster? So we do touch base with all of these things in our cluster architecture or in Hadoop cluster creations. Okay. So just wanted to confirm, guys, quickly once that is my voice still breaking? Any issues in the audio? Can you guys please confirm once? How about you, Shankar? Rory? Okay, thank you. Okay. So there are various ways of Hadoop cluster modes. Okay, so we do teach all the cluster modes, starting from a single node cluster, which is standalone or local mode, and then we move to the pseudo distributed mode, which is again a single node cluster, but here we show all the Hadoop daemons coming up, like name node, data node, secondary name node, resource manager, node manager, job tracker, task tracker, all of these things, and then fully distributed mode. So I do teach building a 8-node cluster. I mean, you can really build a 6-node, 8-node cluster in the Hadoop for the Hadoop cluster, and as a minimum configuration for a 6-node cluster is 6 gigabytes RAM, 6 gigs of RAM with 40 gigs of hard disk drive is enough for me to build the 6-node Hadoop cluster. Okay. Now, more the amount of RAM you have, more the number of nodes you can commission in your Hadoop cluster. So Hadoop cluster does all these modes. So various configuration files you can edit. Hadoop environment.sh, which is being used for setting the Hadoop daemon processes environment, like the amount of memory, log file location, process ID file location. Similarly, for the yarn environment.sh for the yarn specific daemons environment settings, and the core site.xml, which is being used by the name node and the Hadoop distributed file system to connect to the Hadoop distributed file system. So IO settings basically are being provided to the HDFS and yarn here. And then the HDFS site.xml, like any settings for the name node or data nodes, name node directories, application factors, block size, data node location, secondary name node location, secondary name node checkpointing directory, all of those settings you can put into the HDFS site.xml. Then you have got the yarn site.xml, basically configuration settings for the resource manager and the node manager. So where should my resource manager run? Where should the node manager run? How can the node manager will connect to the resource manager? How will the application master connect to the resource manager? All the configuration settings goes into this yarn site.xml. Now, MapRed site.xml basically is required to tell that, okay, how much of memory each mapper or reducer should take, or what is the framework should be used by your Hadoop cluster. I mean, from the processing framework should be used by the Hadoop cluster. You can mention that in this map.site.xml. And then the slaves file. So list of machines, one per line, that will each run the data node and the node manager. So all of these settings, all of these files are the I'll say mandatory files to edit to provide the to build the Hadoop cluster architecture in your laptop, desktop, or the real environments. So configuration files, if we talk about the Hadoop cluster, the newer 2.x architecture can be run with the deprecated property names or can be run with the newer property names. However, it is recommended to always use the latest property names. That gives more edge to the Hadoop cluster. I mean, that looks more easy, more convenient as well, and it's more faster, I mean, say, if you are using the more latest properties there. So these are the configuration files that you need to edit to build the Hadoop cluster. So these are the various daemons which I was talking about. Name node daemon runs on the master node of the. So this is how your distribution will be. Okay. So name node daemon, which will run on the master node of the Hadoop distributed file system. Direct data nodes to perform their low-level I/O tasks. So this is the name node daemon that will run on the first node, master node. Data node daemon that will run on each slave machine in the Hadoop distributed file system, does the low-level I/O task. Okay. Then the resource manager runs on the master node of the data processing system, MapReduce, and it's a global resource scheduler. So name node and the resource manager is the administration node. They are both the administration nodes and going to do all the cluster administration tasks. Node manager runs on each slave node of the data processing system, platform for the data processing task. Job history server. So there is no job tracker in the Hadoop cluster, Hadoop 2.x cluster. That's why a job history server is being provided to get all the to maintain the history of all the jobs in the Hadoop cluster. So we have got 5 daemons here, and secondary name node is optional. If you want to keep, that's fine. If you don't want, that is also fine. So let's just talk about the cloud part as well. So how the Hadoop Hadoop cloud works into the picture. I mean, when we talk about the Hadoop cloud, okay. So how the cloud is best, I mean, for building the Hadoop cluster if you are building it on the cloud. So arranging a large common storage area, providing the secure access to the shared data are the current challenges for the cloud. Okay. Now in Hadoop, okay, in cloud, that is not really there because cloud are like Amazon Web Services or Amazon EC2. So I was talking about the Amazon Web Services cloud here. So cloud is mostly, I mean, if you are using cloud, this is mostly because that you don't have the infrastructure or you don't want to use your own infrastructure and you want basically to test your Hadoop cluster on the cloud. Or if you're really looking for a production cluster setup, then you need the lot of storage on the Amazon Web Services cloud. So a lot of clouds are available. I'll say Google Cloud is there, Microsoft Cloud is there, and AWS Cloud is there. So a lot of Rackspace Cloud is there, but recommended is more Amazon Web Services because they have done all the security specific configurations. They have actually done all the they do have all the type of instances for Hadoop as well to build the Hadoop cluster on the cloud. So just to give you an idea about the AWS cloud itself, you can see currently I'm running the 3 nodes on the Amazon Web Services cloud, where you can see name node, data node, and the client, okay, to build the Hadoop cluster. Now there are like different ways of building the instances as well. So you can launch an instance, and whatever type of instance you want, you can start from here. So Red Hat instance, SUSE Enterprise Linux instance, Amazon Linux instance. Okay, you can even use the community AMIs, okay, which is like machines, or you can say a ghost image which you want to build. You can even build the ghost image out of these machines if you want to start. Okay, you want to create. You can even import your images. Okay, lot of options I'll say. Given, for example, about the simple storage service, which is an elastic service of Hadoop cluster, and that can give you the access to the petabytes of storage in the cloud itself. Okay. Now, if you talk about the EC2 instance types. Okay, so a lot of instances are being provided, especially for the Hadoop cluster. So this is your S3, Amazon Simple Storage Service, storage for the internet. Okay, so that's actually their definition, storage for the internet, which means petabytes. Okay, petabytes, exabytes. You can start with the 1 byte to 5 terabytes, which with your storage, and then you can scale it to any level. So about the EC2 instances, as I told you, especially for the Hadoop cluster, if you want to build, you can see this is the storage type I2, high IO instances. Family includes the high storage instances that provide very fast SSD-backed instance storage, optimized for very high random IO performance and provides high IOs at a low cost. And you can just see the instance type itself, I2 instance with the 4-core CPU and 30 gigs of memory, and it can go to 250 to 44 gigs of memory. This is one of the Hadoop. This is again one of the use cases which Amazon recommends. NoSQL databases like Cassandra, MongoDB, scale-out transactional databases, data warehousing, Hadoop, and cluster file system. So this is one of the instances, and second instance is your D2 dense storage instance. You can see both the instances are kind of the storage instances only, because Hadoop stores all the data. That's where the true power of Hadoop comes into the picture. I mean, you are storing the data into the Hadoop cluster with 48 up to 48 terabytes of hard disk drive based local storage. So you can see 48 terabytes, it can go to 48 terabytes of hard disk drive, and the memory can go to 244 gigs of RAM with 24 into 2000 hard disk drives in GB, which means 48 terabytes. So one instance of 48, you can say, if you are creating like 100 instances like this, okay, so 4.8 petabytes approximately. Certainly it is going to cost you a lot. Okay, I won't really say it's coming like free of cost or something, or it's very cheap. It's going to cost you a hell lot of money. But yes, I mean, if you have that kind of use case, I can totally remember one of the university in, I think, Spain. They started 10,000 node cluster of Hadoop, 10,000 node cluster, just for half an hour they ran on the Amazon EC2 cloud for the processing of their genomic data. Okay, that was related to biology. Now, this is quite possible, but I'm trying to say this because cloud is also a very scalable thing. Okay, Amazon, especially Amazon Web Services Cloud, and its ease of use. Okay, I mean, you just need to start the instances like I have done here. Okay, and you can really start your building your services, or you can start putting your applications on the EC2 cloud. So you can currently see here, this is EC2 instances. Okay, there are 3 running instances right now with 3 volumes. So volumes is something which shows the data storage. So here you can see 8 gigabytes of storage has been given. I have given to each instance with IOPS of 24 by 3000 on each instance, and GP2 is the volume type. So that actually also starts the snapshots. If you want to build the snapshots of each volume, you can use the create snapshots option. For the storage security groups, I mean, whatever ports you want to open, that's quite fine. So it gives you all the actions. Like it's taking a bit of time, I think, from the cloud inside. Okay, and the best part is, I mean, it's all like infrastructure on the cloud itself. And the security groups and the elastic IP address, so you don't have any elastic IP address in this region. I mean, you can allocate a static IP address for an instance if you don't want to change your instance IP address. You can even use the key pair instances, key pairs, basically the SSH keys that will be used for the doing the SSH into the instances. Like here, I've started the Linux instance, and if I want to do an SSH into the Linux instance, this is my Linux instance here. Okay, so you can see that's the Linux instance I'm using, and for this only I've just imported. I'm using a private key, and for this you can see in the authorization there is one private key. So if I just load my so here now you can see a load and private key has been loaded here. And that's my Hadoop cluster. So a lot of activities I keep on doing on the Amazon cloud because this is free of cost. I mean, just for the trial purpose, if you want to do, you can always go to the Amazon Web Services EC2 free tier. So that will give you all the access on the free tier aspects. So you just want to get the hands-on experience on the cloud, use the EC2 free tier. You can see, designed to enable you to get hands-on experience with AWS at no charge for 12 months after you sign up. After creating your AWS account, you can use any of the 21 products we are getting, and services listed below. So which has actually EC2. So 750 hours per month of Linux, Red Hat Enterprise Linux or /t2.micro instance, 750 hours per month of Windows instance, and run one instance at a time or multiple instances simultaneously. Amazon is S3, Amazon DynamoDB, AWS Lambda, AWS Key Management Service. A lot of different services are there. You can just click on show all the products. You can even open it right now on your laptop just to see how it works. So free eligible softwares are being given. Then you have got free tier per month. How about the simple workflow services, Elastic Transporter services? So not being used by the Hadoop, but yes, you can still use their services if you want to in your applications. So this is a bit about the cloud. If you have any questions guys you want to ask, please go ahead. Okay, most welcome, because I want you guys to understand how this Hadoop guy works into the cluster. So just to give you a basic idea, so here I'm running with 3 instances. Okay, now on each instance my name node, so you can see first instance is the stronger one. It has got all the 5 daemons running, which consists of your name node, resource manager, data node, node manager, and the secondary name node. And on the second instance, I'm using the as a slave node. So basically, it's a 2-node cluster, okay, where one of the instances is name node and both the data nodes. And second one is like consists of data node and the node manager. And third one is just a client side. There's no process running on the client side of the cluster. Okay, so it's all about just the data or the jobs that you need to execute from the client. So you don't give the access to the Hadoop cluster on the client. And you want to access the Hadoop cluster, just use the HDFS commands. You can list the data, you can make the directories. So a lot of support is being provided. Okay, you can even list down all the options from the HDFS DFS. So a lot of options, commands are there for this. Okay. These are the most common Hadoop administrator responsibilities, responsible for implementation and administration of Hadoop infrastructure. You can test the HDFS, high-peak, map-reduce access for applications. So not only this, these are listed just a few of them. Hue, Sentry, Impala, Flume, Scoop, all these applications needs to be tested. Cluster maintenance tasks like backup, recovery, upgrades, patching. Performance tuning and capacity planning for the clusters, if you want to do. Monitoring the Hadoop cluster and deploying the security. So a lot of all these activities we do perform in our Hadoop administration course. I do start with the Hadoop version 1 and then upgrade it to Hadoop version 2. I do show all the Hadoop cluster upgrades, high availability, how you can keep multiple name nodes in the Hadoop cluster architecture, how you can do the administration starting from the backup recovery, how you can tune the Hadoop cluster if you want to do, how you can build the Cloudera Hadoop clusters, which actually requires the automation, so how you can do those stuff as well, and how we work in the Edureka. So we do have all the live online classes. So this course is actually been divided into 8 modules with 8 live online classes if you are taking the weekend batches. All the classes are going to be recorded, and all these recordings are going to be input into the learning management system. And the best part is you will get the free lifetime access to the learning management system with no extra charges, and 24/7 post-class support. So even after the classes, if you need any kind of support from the instructors, or let's say from our teams, support teams, you will get the 24/7 post-class support for that. Module-wise quizzes, project work, verifiable certificate, which you can always enable it on the LinkedIn as well. So that part is also enabled now on the Edureka website, and you can go to the Edureka website for any questions or anything you want to ask. So any questions, guys, if you have, please go ahead. Just wanted to quickly give you a glimpse of the course topics which we do in our Hadoop administration course. So starting from the Hadoop cluster administration, basics about what is Hadoop all about, what is big data all about, to bring everybody on the same page. Module 2 covers all the Hadoop architecture and the cluster setup. Module 3 goes with the planning and management of the Hadoop cluster, with the backup, recovery, and maintenance goes into the Hadoop Module 4. Module 5 and 6 covers the high availability of the Hadoop, with the federation of Hadoop distributed file system with the multiple name nodes and the security. Module 7 and Module 8 is all about the Hadoop ecosystem components like Uzi, HCatalog, Hive, HBase, Scoop, Flume, Pig. All these components goes into the Module 7 and 8. And then in the end, we do a project with the Cloudera Hadoop cluster, how you can build the Cloudera Hadoop cluster on your laptop itself with the offline access on the archives of Cloudera. So we do all these stuffs on the cluster in our Hadoop administration course. Now, if you have any more questions about this, please reach out to our edureka.co website and open the Hadoop administration course. So you can see all these upcoming batches details, okay, with the sample class recording if you want to. And there's some 15% early bird off discount as well going on. I just came to know with you guys. So a lot of batches are coming up. With the 13th June is the latest one, and then the 22nd June, 11th of July, 20th of July. You can complete the curriculum. The course curriculum is starting from, this Hadoop cluster administration. You can see the details of our curriculum as well for this course, with the backup, recovery, maintenance, Hadoop to high availability, code of general manager, and all these things. So you can reach out to our facts section to ask about any frequently asked questions if you have. Who are the instructors? We provide placement assistance. Can attend a demo session. Certification as well. You can see all the Hadoop cluster certification. We do a lot of certifications. Sample class recording, if you want to see, you need to join now and start learning. Upcoming batches you have seen, and you can also reach out to our blogs for different topics we have shared with the world. How the Hadoop cluster is being built, what are the different activities and all. The course features, these are the major ones: online classes 24 hours, assignments of 30 hours, project of 20 hours, lifetime access to the Hadoop cluster, to the learning management system, 24/7 on-demand technical support if you need, and get certified. So don't forget to get certified by the Edureka when you have completed the Hadoop project via our course itself. Okay. So various course reviews, you can just follow our website and you can follow the LinkedIn, okay, to check out our course reviews. And the best, another important part which I've just seen with you guys only, offer is Get Linux Fundamentals, absolutely free, limited period offer. So if you don't have much of the Linux visibility, please do access our Linux Fundamentals course as well. So that is freely coming for this course as well. So that's how it works, guys. Any questions, any doubts, anything you want to ask, please go ahead. Okay, so any questions, Pratap, Ravi, Rory, Sandeep? Okay. Anything you want to ask about this course, about the instructors, about anything, do reach out to our website as well, or you can directly ask from me. Anything technical you are looking for, please not shy about asking. We do support everything from our website as well as via our learning management system. If you want to call our sales team, please do call these numbers from US and India. We have mentioned that on our website as well. Do not forget to please fill about the review form, just the feedback form. Okay, so that you can tell us, okay, what all things are missing, what all things we should include in our course, or any other comments if you have. Okay, you want to learn. If you want to learn any specific topics, we do cover that aspect as well. Question, are you able to do the Cloudera administration certificate after this course? So Cloudera do provide the administration certification, that's right, Tori. Second part is, see, I do cover 80% of the certification which Cloudera does, okay, 80% of that which Cloudera does in the administration course, okay, but 20% I don't cover really. The reason is I want, I've actually put all that 20% to you guys, on you guys, okay. I want you guys to cover, to explore more about Hadoop. I mean, if I keep on telling you everything, then it will make you guys lazy. So I don't want that. 20% I don't cover at all, and 80% is what I do cover. But yes, after the completion of the course, when you go through the Cloudera administration certificate, you will see that it's actually not 80%, it's almost the 100%. While some of the other things, certainly you need to go through yourself to see how it works. So I do recommend some books as well for that, okay, because it's not that easy certification and very much in demand. So one of the important part I want to make you guys understand that, see, there is no requirement of Java for this course, okay, and you need to have the basic knowledge of Linux. So the prerequisite for this course is basic knowledge of Linux. If you have that, then that's quite good, okay. Else you can always take our Linux course, which is absolutely free right now, coming up with this course. So there's a question from one of the participants. Once you are done with the course, how long does it take to get placed? So we don't do any kind of placement here certainly after, but what I would say is it's not something I am doing some magic here, okay. So I would again say that, okay, if you have understood all the 8 modules, if you have done all the practice of all the modules, I mean, if you have completed all the assignments, then I don't think so it should take more than 1 or 2 months to get placed into the companies. The reason is we do cover all the aspects of big data technologies, okay, certainly in detail about the Hadoop. So which companies are looking for, okay. Now if you say that, okay, will I be having any real-time production support here or anything like that? No, we don't provide any production support. We don't handle any production issues, but we do provide all the support related to our courses, okay. So good guys, I think that's all from my side, okay. Please do fill the feedback forms if you have any comments, queries, or anything you want to say about this webinar, or anything you want to ask about the Hadoop administration course. Or you can always reach out to our website as well, edureka.co, and drop us a query here. You can see a small form is being given, and you can also reach out to our Hadoop administration course page to see what all things are being provided with this, along with this course, okay. I would say there are 2 important aspects, again, just wanted to highlight here. One is the lifetime access to the learning management system and lifetime support as well after the end of the course, which we do guys for you guys, so that you should not face the heat even after the ending of the course itself. So that's all guys. Thank you so much for joining in. Hope that you have got the enough information about this webinar, about the course, and about the Hadoop as well. See you in the next webinar. Cheers, good night, good day.